In algebra, we like to turn complicated expressions, like this one at the top here, into simpler ones. This one is very complicated. It's got lots of parts to it. And the parts are called terms. When I look at this formula, or this expression at the top, this expression, you'll notice there's an x cubed, a plus 10, a plus 12x squared, a negative or subtract 3x squared, a positive or a plus ax squared, a subtract 9, a plus 6x, and a subtract x cubed. Now looking at that, you can see I've got 1, 2, 3, 4, 5, 6, 7, 8 terms. So what are terms? Terms are parts of the expression that are separated by pluses and minuses, by positives and negatives. So terms have plus or minus between them. And the important part is the plus or the minus goes with the term after it. So this negative here goes with the x cubed. This positive goes with the 6x squared, etc. Now, some terms are like. This is a very important part of algebra. If a term is like another term, we can add them or subtract them together. To be like, they have to have exactly the same letters. Now let's have a look at this one up at the top here. You will see there's an x cubed. X cubed really means x multiplied by x multiplied by x. So when you think about it, that's not the same as x squared. X squared is equal to x multiplied by x. These do not have the same letters. They have x's, but there's more x's here. So when you see x cubed, think of it as xxx. When you see x squared, think of it as xx. X is not like x squared. X squared means xx. X cubed is not like x. So let's have a look. There's an x cubed here and an x cubed there. They're like. I can add and subtract them. There's a 12x squared here, a minus 3x squared there, and a plus ax squared. These two are like, they have the same letters. This one is not like those. The a and the x together and the other x, so this is really axx, is not the same as xx, and it's not the same as xx. X squared and x squared are the like. Ax squared is not like them. X is not like any of the other ones here. This is the only term that has just an x in it. This has got xxx, this has got xxa or axx, this has got xx, and this has got xx. So let's add and subtract the like terms. The way to do that is just to start at the front of the expression and look for ones that are the same and cross them off as you go. Now there's an x cubed here and a negative x cubed there, so they actually end up being nothing. So there are no x cubes. I could write it like that, or I could just leave it out. Looking at the next thing, there's a number with no x's or a's or any other letters. There's just a 10. There's also a minus 9 over here. Both of those are just numbers. They're constants. So 10 take away 9 is 1. So this 10, this plus 10, and this minus 9 make plus 1. Looking again, there's an x squared term here and another x squared term here. This one's not the same. It's got an a in front of it, so it's a different term. It's not like the other two. So if I take the 12x squared, which is positive, and the negative 3x squared, that's going to give me 12 take away 3, which is 9 plus 9x squareds. So I'll cross those off because I've done those, and I've also done this, so I'll cross that off. Now let's have a look. What's left? Well, we've got this ax squared and this 6x. I can't join them together because they've got different letters, they're not like, so that means I just have to leave them as they are. So at the end, this term here and this term here stay as they are. Which means the final answer is equal to 1 plus 9x squared plus ax squared plus 6x. In this next example, these terms don't look at all like, but let's be careful because there's an x here, another one there. They're all multiplied. So what we need to do is actually simplify it first by using indice laws. So if I've got x multiplied by x, that's actually x squared. So inside this term here, there's an x squared. There's also a y squared and a y, which makes y cubed, and a z. So I can rewrite the first part, the first term, into x squared y cubed z. Subtract. Having a look at the second term, this term here, with the negative here, or subtract, it's got two x's again, x squared multiplied, three y's multiplied, which is y cubed, and a z. So it's actually exactly the same term as the first term. These terms are alike. They don't look like at the moment, but I've changed them using index laws so they now look like. And if I was to subtract that, I'd get no x squared y cubed 7 z's, which is 0. In the second example, having a look at this one here, we've got 6y squared pq squared on the top, and x, and underneath we've got 3y squared q. So what I'll do is, because some of you might not know about indice laws yet for division, I'm going to just expand it out. So this is really 6yy, which is y squared. So y squared means y multiplied by y. And then I've got p and q, because there's two q's there, and an x. And that's divided by 3yy q. So I can cancel here because there's a y there that can cancel with that and go one time, and a y there that can cancel with that y and go one time, and a q here that can cancel with that q and go one time. And 6 and 3 cancel because 3 goes into 3, 1, and 6 goes into 6, 2. So that means I end up with 2 on the top and times 1 times 1 times 1, which stays 2. And then there's a p, q and an x. Underneath it's just a whole lot of 1s, which means that underneath it's just divided by 1, which is another way of saying you don't need the 1 underneath. You can just write it as 2pqx.